Okay, today we're going to look at combinations again, but these are going to be a little bit harder. So we'll go through a couple different scenarios, but we'll kind of base it all on the same question. So let's suppose we have 10 people, and out of the 10 people we have 4 males and 6 females. Okay? So let's do a couple of different scenarios all based on the same thing. So let's suppose the first question we're going to look at will be, how many different combinations could you have where you just pick 4 people total? So we want any 4 people, males, females, it doesn't matter. We'd have 10 to choose from. And we want 4 people. Order doesn't matter, so we use C. So 10C4 would be the answer for that one. Okay, so now, for our second one then, let's look at what happens when we combine the word and in there. So this would be, we want to still pick 4 people out of 10, but in this case I want to do a group that has 2 males and 2 females. Okay, so still 4 out of 10, but now we're going to get more specific where we want 2 males and 2 females. So in this case, when you go to do this one, you have to be careful because we're now just picking 2 out of the 4 males. So you'd have 4C2, and then and means times, remember that, so and is times, so then you'd have, okay, so you'd have 4C2 for the 2 males, and then we'd have 6C2 for the 2 females. And that would be it for that one. Okay, let's do another one where I say I want to get 2 males and 2 females. Actually, I'll write it a little different. So we're going to say we want 2 males and 2 females, or 3 males and 1 female. So in this case, we sort of have 2 different options. So you'd have 2 males and 2 females, which is exactly what we just did in question B. So you'd have 4C2 times 6C2. So that'd be the 2 males and 2 females. Then we have or, so remember with the word or, that means plus. So then we have to add, and then we do it the exact same thing all over again. So now we want 3 males, so that'd be 4C3, right? 3 out of the 4 males, and 1 female. So then we'd have times 6C1. Okay, so in this case, the or just means plus. You got to do 2 and 2 plus 3 and 1 for the second part. So that'll lead us into the next 2. So the next 2 are sort of the same. It's when we say we have at least or at most. So we'll kind of stick with the exact same question. So now for this one, we're going to say, how many combinations would we have where we have at least 2 females? Okay, so what you have to do with that one then is kind of combine what we did in the previous 2. So to have 2 females, that means you'd have 2 females and 2 males. Or to have at least 3, so that means we can have 2, or we could have 3 females, so 3 females and 1 male. Or 4 females and 0 males, right? Because if we're taking a group of 4, and we want at least 2 to be females, so you'd have 2 and 2, 3 and 1, or 4 and 0. And then from there you do the exact same thing. So we have 2 out of the 6 females, and 2 out of the 4 males, or would be plus. Then we have 3 out of the 6 females, and 1 out of the 4 males, or 4 out of the 6 females, and 0 out of the 4 males. You don't need to worry about the 0 part, because 4C0 is equal to 1. C0 of anything would be equal to 1. So this you could sort of just ignore that part. So when you do 4 females, you could just do 6C4 and don't worry about the males at all. So all 3 of these answers then you'd have to calculate and then add together, and that would give you the at least. So if we do another one where it said how many would have at most 3 males. So we do the same sort of way. You'd have to have at most 3 males, so you'd have 0 males and 4 females, or 1 male and 3 females, or 2 and 2, or 3 and 1. Okay, so that would be the other option. When you do at most, you just start at that one and go up. So at most 3 would be 3, 2, 1, or 0. And then from there it would be the exact same thing. We'd have 4 at a 0, which we don't really need to worry about. We could skip that one, right? Because we've done these zeros we don't have to worry about. So you just have 4 females, so 6C4. Then we'd have 1 male, so 4C1, and 3 out of 6 females, and then 2 and 2, and then 3 and 1. Okay, so that would be the way you do that one. You'd have to figure out all of them and add them together. But for this one, you can see it's quite a bit of work. There's 4 different steps, and you could go from there. But the way you could do this one is to think of the word not instead. So if you look at this one, it says at most 3 males. So that means we could have 0, 1, 2, or 3 males. So the only thing that we would do is we would want not 4 males, right? If the question is how many have at most 3, basically we could do every combination except for 4. So the last one we want to look at is how to do the not. So if I said not 4 males, so how many different combinations don't have all 4 being male, the way we do that one, it's sort of just like when we did Venn diagrams. The not was sort of the complement. So if I said this one was 4 males, the not 4 males would be everything on the outside, and in this case, this would be our question that we want. That would be 0, 1, 2, or 3 males. So to get the universals group, that would be the total combinations. So to calculate this one, you could just do the total combinations and then subtract the 4 males, right? If we don't want 4 males, we could just do the total minus 4, and that would be the not. So the total we already did right at the very first part, right? We had 4 out of 10 people, and then 4 males would be 4 out of 4, and that will be the same answer. So this answer for not 4 males, doing the total minus the amount, would be the exact same thing as what we did here with adding up the 3, 2, 1, or 0 males. Okay, so either order would work. So some people like to just do all the different ones and add them up, but in some cases when you only have 1 or 2 that aren't included, sometimes it's easier to do the total minus the not. And we'll do some practice questions on that, and that is it.